Hello, how you guys doing tonight? This is Eric Barber, and I chose time complexity for my database decision project. First, I would like to start off by saying this research had a lot of impact on how I was able to wrap my head around the concept of time complexity. In the following research, I have noticed that there is one key concept to the time complexity mindset and the way that it operates. Time complexity is more of algorithms and math to be able to determine how long it will take for a program to run. As you can see on this slide here, there's several different types of algorithms for the process to be completed. O1 algorithm, it costs you one operation and is actually the most effective one there can be all the way through the amount of data that you are trying to process. The least effective one that I have found so far is ON squared. Let's say, as in this example here, there's 2,000 elements that need to be processed. For the ON squared algorithm, there's over 4 million operations that need to be performed. But as the amount of elements that increase, it gets drastically worse, but with O1 it stays the same. The key concept to this is that it's not the amount of data that slows down the system. It's more of the amount of operations that the program has to complete in order to process it properly. In this slide here, there is O1 versus ON squared, as I was just discussing. Next, I found this paper about how the big O notation is an extremely broad and detailed subject. There is so much information that goes into this subject that you really can't grasp it 100% because it goes into the mathematics part of it as well as the programming side of it. Here's an example of a O to N algorithm. It basically describes it in a coding aspect to be able to understand it in a more clear manner. It's a simple if conditional. If this statement is true, then you will return this and add or subtract or whatever else it may be. That would be an example of O to N. Right here is an ON. It is a linear sort of path that it takes with the more data that you get and the more operations that need to be completed. For each is an example. Inside this for each you have an if statement. As you go into more depth, it could be a for loop with an if statement in it. It could be a while loop with an if statement in it. As long as it goes into depth, is the more operations that need to be completed for this step to be completed. Here's an example of the really bad ON2 method when it comes to massive amounts of data anyway. You have a for loop inside of a for loop. Inside that for loop you have an if and another if. As you can see, as the process becomes worse, there's more layers within each conditional and loops. As you can see here in this final slide, that as the amount of data increases, the number of operations that need to be performed increases. As you can see with the O1, as I was describing earlier, it stays as one step all the way through the amount of data that it has to cycle through. And as you can see with the pink line, ON squared, as described earlier, as the number of data increases, the number of operations increase substantially as well. Now the part that I did not discuss in this video is the O log n. That is kind of like a happy medium between the two. It's kind of like a half a parabola is a good way to think about it. And that completes my presentation for this evening. Here's my references page, and I would like to wish you all the best, and if you have any questions about anything in the class, let me know. I will try to help as best as I can. Thank you very much. Have a good night.